Hello students, welcome back to Motion in One Dimension. We have seen maths that is required for physics in the last two sessions. Okay, so that mathematics which we have learned, we need to apply in today's class. Okay, you might be remembering the differentiation formulas. Okay, I believe. So here what the topic which we are going to study today is instantaneous displacement, velocity and acceleration. Instantaneous velocity and is instantaneous acceleration. Okay, instantaneous velocity and acceleration. So what is an instant? Instant means in Tamil we say nodi. This is what is an instant. Suppose if you are driving a car and you are moving, then your friend is standing beside me and he is asking me, sir, what will be his driving speed now? So if I am able to tell the speed now, and now he is moving at 20 kilometers per hour, that it's instantaneous speed, okay, or instantaneous velocity, vice versa, based on the situations. Suppose if you have started from your home at 9 o'clock, you reached here at 10 o'clock. So the speed with which you might have started, you started with a zero, from zero velocity, then increased slowly. In between traffic jam was there, you stopped sometime, someone crossed the road, you suddenly applied brake. So various values of velocities and accelerations you might have applied. So after reaching here, you may tell me like, sir, I came by on an average by 30 kilometers per hour, too much traffic was there. So I came by around 40 kilometers per hour speed I had. You will tell that. Doesn't mean that you started with the 40 kilometer per hour, you ended with the 40 kilometer per hour. In the traffic block you were driving with the 40 kilometer. No. In between some places you might have came at 60 kilometers per hour or 70 kilometers per hour, sometimes zero also. So we say average 40 kilometers per hour. So how we found the average velocity? You might be remembering the formula. Average speed or average velocity is nothing but the sum of all the displacements and divide by sum of all the time. This is what average speed or average velocity. Okay, so this is what is average speed or average velocity. Now the formula which we used, V is equal to U plus AT, V square is equal to U square plus 2AS, S is equal to UT plus half AT square, Sn is equal to U plus A into N minus half. All these equations of kinematics, we can apply only if we have a single value of acceleration. You agreed? We had a lot of discussion on that. If we have single value of acceleration, if the vehicle keeps on accelerating or keeps on decelerating, in these kind of situations we can use this. Or otherwise, if we have two instances like increased the velocity, decrease the velocity at the same rate, increase the velocity at alpha, decrease the velocity at beta. We have done some questions like that. These kind of situations also, by splitting the motion, we can apply this and get. But if you have lot of acceleration, lot of velocities value, not really lot of velocities value, here also lot of velocities value you will have, lot of accelerations, we cannot apply these equations. Clear? So in that case the accelerations keep on changing, correct or what? So in those kind of situations we will have to apply differentiation or integration. Integration we have not studied, we will have in the coming sessions. Now we will apply only differentiations. Okay, differentiation. So we will have to apply calculus mathematics tool to get the answers. We cannot apply this here. But if you know this mathematical tool, differentiation and integration, then you can apply that method for this also. Even for single acceleration method also, the coming method which we are going to learn can be used based on the situations, because that tool, this calculus or that method differentiation is correct in every situation. It is perfectly correct in every situation, but this cannot be applied there. That can be applied in all the situations. Now this is what is about average velocity, average speed. Okay, and now we will see what is instantaneous acceleration. Suppose instantaneous velocity, suppose if it is moving like this from A to B and to C. If this is going for a velocity v1, if this is going at velocity v2, we have seen some situations. What is the average velocity? We know V average is S1 plus S2 divided by T1 plus T2. But if they ask what is the instantaneous velocity, instantaneous velocity at a time t is equal to, this is important. Now throughout the motion, when we find average velocity, we just need time duration. This is T1, this is T2. We just need what? We need only time duration. We don't need that particular instant, we don't require. But if someone asks what is the velocity at this moment, this one particularly, this instant, then definitely someone should tell us at t is equal to 3 seconds. This doesn't mean that for duration t is equal to 3 seconds. Not duration. Not duration. If this vehicle started here at t is equal to 0, this is t is equal to 1 and this is t is equal to 2. So at t is equal to 3 seconds, what is the velocity? Or we can say, if you are driving your vehicle at 9 o'clock, 10 minutes, 10 seconds, at that instant, what was your velocity? If someone asks you that, you will have to give a specific value. Now since from here to here, since this velocity is given as v1, I can say, yeah, right, at v instant t is equal to 3 seconds, velocity is v1. Here, if t is equal to 15th second or something like that, 15th second, what is v instantaneous at t is equal to 15th second? Means if here the velocity is given as v2, I can write v2. Only two velocities are given. So in these kind of situations, I can write like this. Okay, now you note it down, pause the screen, note all the data, understand it well. Now suppose someone started from here, moving like this. Yes, so this is the initial point, this is the final point. Took all these paths. Okay, now this is the initial point and this is the final point. If someone asks us what is the displacement, what is the displacement, what we will do? This is the initial point, this is the final point. We will mark like this. This is the displacement. From where? From here to this. This is what is the displacement, correct? What is the direction of displacement? Direction of displacement is this, very clear. Direction of displacement. Suppose this is coming like this. Here someone asks what is the direction of displacement at that instant. Say for example, at this position t is equal to 25th second, the position of the vehicle or body is there. Okay, so this is final position. I write this position as x. So at x, time is equal to 25 seconds. At the 25th second it has reached there. Now someone is asking what is the displacement, direction of displacement at t is equal to x, 25 seconds or at x. Then what we will do, we should consider this as the position. We will mark displacement in this direction. So direction of displacement is this now. This is the direction of displacement. Clear or what? So at this instant displacement is changed. At that instant displacement is now not total displacement. This has changed. Likewise, vehicle is moving like this. Okay, when it reached here, what is velocity? What is velocity? So this is what here they are asking, instantaneous velocity. Instantaneous velocity at a time they will be giving. So how to find this? How to find this? That is what all the discussion about. Okay, clear? Did you understand very clearly? Okay, now at this position, okay, generally, but let me ask you one more thing. What is the direction of velocity in this displacement? Between initial point and final point, what is the direction of velocity? This is the direction of displacement. This is the direction of displacement. That is the direction of velocity. That is the direction of velocity. Okay, now we saw this is the direction of displacement here. From here, this is the direction of displacement. What is the direction of velocity in this? Velocity in the sense, what is the direction of instantaneous velocity? At that point, what is the direction of instantaneous velocity? See, when we take, this is average, this is average, this is also average. When we are asked to find the direction of instantaneous velocity, this is nothing but the velocity at this moment. Velocity at this moment, that will be this direction. In whichever direction it is moving, that will be the direction of instantaneous velocity. But speed doesn't have any direction also. Speed doesn't have any direction. So instantaneous velocity direction will be the direction of velocity at that moment. So that will be you saw that at that instant what is the direction. Average velocity direction will be, draw a line, whatever be the direction of displacement, that will be the direction of average velocity. Now we will get into the details of it. Okay, so someone is running in this direction. Okay, so this is a curtain. In this curtain there is, okay, he is running. Okay, he is running. Now this is completely covered. At 2 points a slit is opened. Okay, here also a slit, here also there is a slit. Now we are not able to see how this fellow is running. He is running, okay. Now we have two slits, so the person looking from this side absolutely will have no idea like in what speed he is running. But someone who is good in thinking will understand that by reading the time between this slit and this slit, okay, if it starts from here, if this is T1 and this is T2, and we know the difference between these 2 points also, okay. Say for example this is x1, this is x2, okay, like this, x1, x2, okay. So if we know this time duration, okay, time duration, and this we know this slit, then we will be able to find velocity. V is equal to x2 minus x1 by t2 minus t1. Clear or what? Okay, this is what. Now if this difference is very short, if it is very distance is very much, then we will be able to predict it easily. But if that duration is very small, then we won't be able to recognize like this, because this v is nothing but delta x by delta t. From this I can write, if delta t tends to 0, not 0, tends to 0, when it becomes 0, we cannot find that easily. So there comes, what we do is, if there is only one slit, between this we need to find. In these kind of situations, what we do is, we will take this as T2 and this as T1. That is why we say delta T is becoming 0, very small. So the small time duration we will take and we will calculate. So if delta T tends to 0, V is nothing but dx by dt. So for this small time duration, in the previous sessions we have seen, small time duration we will, even if it is a curve, we will consider that as straight line, and we apply the formulas of differentiation. Okay, so this is just for your understanding. I have explained this. Whatever we require is, we will get a function of velocity, acceleration or displacement. We will apply the formulas of differentiation and we will get the answer. Alright, so suppose if we get position, okay, as a function of x or function of t, okay. So we will be getting x just like a function of t. So x is a function of t. Function of t means x varies with the time, position varies with the time. Just like example will be like a t square 2t plus 1 or something like that we will get. And we know v is equal to delta x by delta t. So this is nothing but, and delta t is very small, delta t tends to 0, v is nothing but dx by dt. And we know how to differentiate a function. D by dx of x raised to n is equal to n x raised to n minus 1 we have seen. If d by dt of t raised to n is nothing but n t raised to n minus 1. This is differentiation formula we have seen in the previous sessions. Just like that. What is acceleration? Acceleration we know delta v by delta t. Rate of change in velocity. Already we have seen. So in this case, again delta t tends to 0, we will have acceleration is equal to dv by dt. So this is what we need to solve the questions that comes under this part. Clear or what? Note it down. Okay, So x will be given, we need to find v is equal to dx by dt, and velocity they will be given as a function of time, like this will be one thing, another is v is equal to f of t. Velocity will be given as a function of time. Then to find acceleration we will do dv by dt. Clear? So position will be given. To find velocity, differentiate that position with respect to time. Velocity is given. To find acceleration, differentiate velocity with respect to time. Okay, we know differentiation formulas, just apply that formulas in the equation of position to find velocity. Apply the formula of differentiation on velocity to get acceleration. So same way acceleration will be given, we will be able to find velocity, we will be able to find position, displacement, that is also there. Position means what? Displacement from origin. Okay, displacement from origin. Okay, right. So this is all about. Okay, but reverse, acceleration will be given to find velocity, velocity will be given to find displacement. These things we will learn after learning integration. Okay, that we will be able to do after studying the mathematical tool integration. Okay, so this topic will be easy for you if you have revised differentiation formulas and all very well that we have taken in the previous session. Okay, so shall we move to do some questions? Students, see this question. The displacement of a particle moving in a straight line is given by s is equal to 2t square plus 2t plus 4, where s is in meters, that is the unit of displacement, and t in seconds. The acceleration of the particle is, clear? Question is clear? Now we have displacement is given, that equation we will maintain here. Okay, remaining things I will erase. Now displacement is given, s is equal to 2t square plus 2t plus 4. What we need? We need to find acceleration. Acceleration is nothing but dv by dt. Now we don't have velocity. So how to find velocity? Velocity is nothing but dx by dt I said. Now here displacement is given us in the form of s. So ds by dt. We know d by dt of t raised to n is nothing but n t raised to n minus 1. This is the differentiation formula. So that I will apply here. D by dt of 2t square plus 2t plus 4. So this is equal to, this 2 we will keep here, this t square, this 2 will come here, t raised to 2 minus 1 is 1, plus 2 we will maintain there. Here actually 2 raised to 1 is there, so t raised to 1 minus 1 is 0. Differentiation of constant is 0. Differentiation of constant is 0. You might be remembering, see, slope d by dx is what? Actually d by dx is nothing but slope. dy by dx is nothing but slope. So if this is what, when I write here this one 4, when I write 4, this is nothing but a straight line. So its slope dy by dx is nothing but 0. If slope is non-zero, it should have a appearance like this. All these basics we have seen. I am still revising it. Okay, so what we are getting? 4t plus 2. This is the equation of velocity. This is the equation of velocity. Now to find acceleration, acceleration is what? dv by dt. So d by dt of 4t plus 2. Differentiating this, we will maintain 4 there. Here nothing but 2 raised to 1. Sorry, t raised to 1. So t raised to 1 minus 1 is nothing but 0. Differentiation of this constant is again what? 0. So 1 minus 1 is what? T raised to 0. 4 t raised to 0. Anything raised to 0 is what? 1. So answer is 4 meter per second square. Look at the option B. Clear? They asked the acceleration So what we did, acceleration can be found by differentiating velocity. So what we did, we found velocity by differentiating this. So when we differentiate, we just apply the differentiation formula in each term. So we will be getting differentiation of constant is 0. See, since this is the first problem of this type, I am doing step by step slowly. Once you catch speed, when you are able to do very fast, fatafat you should do. Okay, note down. See, this is the question. Now I have done step by step. Now how you should approach when you get a question like this, how you should do differentiation generally. Okay, you should be able to do directly. Question is acceleration, right? Question is acceleration. So we need velocity 4t plus 2 bus. Differentiate it directly there. Bring the 2 here. Just 2 minus 1 t, you know. This is t, so t will go there. This will be 0. So directly write like this. When you need to write acceleration, just write 4 bus. You should do fast like this. Okay, directly don't write steps and all. Steps can be written initially. Today's class you can write. Even when you practice also you write. But you should do lot of such problems that you should be able to do directly. Tuck tuck. Okay, so it will take hardly 10 or 20 seconds. Save the time, spend your time in the next question. Okay, time management is very important when you attend competitive exams. I think you know all that. Okay, so this is how you should handle this question. We'll go to next question. So students, this is your next question. The position x of a particle varies with the time t as x is equal to a t square minus b t cube. This is function. This position or displacement is a function of time. Importance of function. Okay, the acceleration of the particle will be 0. Acceleration of the particle will be 0 at the time t is equal to. They need at what time acceleration will be 0. They need time. Options are given like this, not 2 seconds, 3 seconds, something like that. They have given in the form of equation. So how to approach this problem? Okay, so position is given. Okay, x is equal to a t square minus b t cube. Now to find acceleration is equal to 0, we need to find the equation of acceleration. If we get the equation of acceleration, equate that to 0, keep time in the left hand side, whatever goes to the right hand side, we will be getting the answer. As simple as that. So first we will find velocity is nothing but dx by dt. So this is nothing but 2 will come this side, 2at minus 3bt square. Okay, so with the practice we have done in the physics for mathematics sessions, you might be pretty comfortable here. Okay, if you have done practice, you can write directly. So this is the equation of velocity. Now how to find the acceleration? dv by dt, differentiating this one. Okay, so this is dx by dt, this one here I haven't written, but I am writing directly. This is nothing but by doing d by dt of what? X, a t square minus bt cube. Okay, same way d by dt of what? This one, 2at minus 3bt square plus. Okay, so what? This is going to be 2a. This t raised to 1 will become 1 minus 1, t will become t raised to 0. So t raised to 0 is 1. So 2a minus 2 will come here, 6bt. Yes. So this is the equation of acceleration. Clear or what? This is the equation of acceleration. Now what we need? We need time at which acceleration will become 0. So a is equal to 2a minus 6bt will become 0 at what time? At what time? So equate this. So what we will do? Minus 6bt is equal to minus 2a. So t is equal to this signs will get cancelled off. 2a by 6b. So this will get cancelled off. We will be getting a by 3b. A by 3b. Option C. Clear or what? So they need not ask the questions directly just by giving displacement what is velocity, just by giving displacement what is acceleration. They may ask like this also. They will ask the time instant at which acceleration will become 0 or acceleration will become 4 meter per second square. Anything can be asked. Okay, note it down. So then take this question. The displacement of the particle is given by y is equal to a plus bt plus ct square minus dt raised to 4. The initial velocity and acceleration. The initial velocity and acceleration. So pause the screen, do this for yourself. I will give you the hint for this question. Initial velocity and acceleration is nothing but velocity and acceleration at which time t is equal to 0. Initial velocity means what? At a time t is equal to 0. So find equation of velocity, equation of acceleration from this. Substitute time t is equal to 0 in the equation, you will be getting the answer. Okay, pause the screen and do for yourself. Yes, so this is velocity. Differentiation of constant is 0. Differentiation of bt is b. Differentiation of ct square is c2ct minus dt raised to 4 is nothing but 4 dt raised to 3. Now initial velocity is nothing but v at t is equal to 0. So the answer is B, because everywhere this will become 0, this will become 0 when I substitute t is equal to 0. So what is the answer? A also can be, C also. If there is only one option, directly mark that answer and go to the next question in your exams. Okay, here even if you have different options also, we need to try because we are studying. So A also can be or C also can be. So what is acceleration? Differentiation of velocity. So differentiation of what is velocity? V is equal to b plus 2ct minus 4dt cube. Correct or what? Now acceleration is what? dv by dt. Okay, velocity I did not write just because we have done some questions. So dv by dt. Differentiation of v will be b will be 0. This is going to be 2c, and differentiating this will become 3 will come here, 12 dt square. Now acceleration at a time t is equal to 0, when you substitute all the values of t is equal to 0, this will become 0, and this is going to be 2c. So option C is the correct choice. Correct? Note it down. So nothing, just differentiating displacement or differentiating position, you will get velocity. Differentiating velocity will get acceleration. Differentiation formula, that too for polynomials, you know very well, it is quite easy. And if you need time, substitute the value of time. Okay, if you need to get the answer time, at what time instant acceleration is 0 or 4, then put the value for acceleration and find time from the equation. That's it. Okay, we'll do next question. This is your next question, students. The relation between time t and distance x is t is equal to alpha x square plus beta x, where alpha and beta are constants. So what is the retardation if v is the velocity? So here you need not pause the screen and do this question. This is a little complication is there. Okay, and okay, if you are very good in differentiation, if you have done well, okay, try, but here a little issue is there. So see students, the problem here is we don't have the equation in the as function of time. If we have 3t square plus t, something like this, then it is easy to differentiate and proceed. It is not like that. So, okay, this is, they have given the equation of time. Moreover, even if the equation of time is like this, suppose 3t square is equal to 2x square plus 2, something like that is also there, then what we can do is 2x square is equal to t square minus 2, then x square is equal to t square minus 2 divided by 2. So from this, x is equal to root t square minus 2 divided by 2. Even if you get in this form also, we can do this. So, but this we cannot separate this. We cannot separate x is equal to in this form also. Okay, x is equal to t by alpha something, we cannot separate this. So that is the problem here. So how to do this question? Okay, so take this example also. Okay, if v is the velocity. Okay, take this example also. Take this example. First we will do that, then we will go to this question. Okay, right. Okay, so suppose if we get t is equal to 2x square plus 2, then we will separate this and we can do. So how to do? What is this x? X is equal to t square minus 2 divided by 2 whole root. Okay, so if we could make the equation into this form, if this is the displacement or position, how we will find velocity? X is equal to t square minus 2 all raised to 1 by 2 I can write. This is root 2, correct or what? Root 2 can be written like that full term raised to 1 by 2. So by chain rule we can do this. First we will consider, just keep this 1 by 2 apart, t square minus 2 all raised to 1 by 2. How to differentiate this? In the session physics for mathematics, we have discussed the chain rule. So by using chain rule we can do this. How to do? 1 by root 2 into, put this, take this entire term as what? One single variable. Consider this t square minus 2 as t. Approach like that. So 1 by 2 n t square minus 2 all raised to 1 by 2 minus 1. Okay, then after that what we should do? Inside, what is the term? Differentiate this and write. So this is how. So what will be the answer? 1 by 2 root 2, then this is going to be t square minus 2 all raised to minus 1 by 2 into 2t, correct? So this 2 will be cancelled off, and what we are going to get is v is equal to, okay, this is v is equal to what? T into t square minus 2 all raised to minus 1 by 2 divided by root 2. This is what is velocity. So again, if you need to find acceleration, you need to differentiate this. To differentiate this, you know uv method, likewise you can differentiate. Okay, so just I was telling the method, like how we need to do if you are able to separate the things. Okay, note it down. Clear? So this is just I gave you one question inside another question. This is a separate question, dear students. Okay, now the real question is this: t is equal to alpha x square plus beta x. Okay, how to do this? This is the question. See, the question which I gave in between is just I gave an example, like even if they give t is equal to something x, if we are able to separate x equal to the other part, then also we will be able to differentiate. Just we can find velocity and acceleration. That is what I gave. Just I took a difficult example, just having root 2 and all, root and all. Okay, that's it. Now this one, this is the real question. How to do this? See, here velocity can be written, what they are asking? They are asking retardation, acceleration. So acceleration can be written in this way also. dt by dx into dx by dt. Sorry. Acceleration is actually dv by dt. So in this, dv is what? dv is nothing but dx by dt. dx by dt. So into here 1 by dt is already there. Okay. Now this can be written in what form? This can be written by, we can have like dv by dx into dx by dt. Clear or what? Acceleration is something but dv by dt. Okay, we know that. Now dv is actually dx by dt. Velocity is what? dx by dt. And I just say maintain 1 by dt like that. So other than that, acceleration also can be written like dv by dx into dx by dt. If we cancel dx and dx, this will become this term. Correct or what? This will become what? Same as this. If I cancel dx and dx. Agreed this? Did you understand? Acceleration is equal to dv by dx into dx by dt. I can write in this way also. Okay. See, this is the general method we have understood. Now velocity can be written like a dx by dt also. Clear or what? Now in terms of velocity, I can write acceleration in this way also. Okay, so this relation you can write and keep it there. Okay, this is also not required. This is also not required. This is our regular formula. This one, a is equal to dv by dx into dx by dt. So remember this. Okay, remember this. Now what we do is, we have got t. What we will do? We will differentiate dt with respect to dx. So d by dx of alpha x square plus beta x. Alpha x square plus beta x. Now when we differentiate this, dt by dx is equal to, differentiate with respect to x, we will getting 2 alpha x plus beta. 2 alpha x plus beta. Now dx by dt is nothing but velocity, which is nothing but 1 by 2 alpha x plus beta. 2 alpha x plus beta. Clear? Note it down. Now I got v, that is, this part is nothing but v. This part is dx by dt is nothing but v. Okay. Clear? Now I am erasing this. Just I will maintain this here. A is equal to dv by dx into dx by dt. Okay, this is the formula. If you remember this, if you follow that formula, easily we will be able to come to the answer. So one side is ready, dx by dt is ready. Now this is v, na? V is what? 1 by 2 alpha x plus beta. Now if we differentiate this with respect to x, we will get this term also. This term is ready, it is here. Clear or what? Now what we will do? dv by dx is nothing but d by dx of 1 by 2 alpha x plus beta. Now how to differentiate this? Simple. What we will do? We will bring to the numerator, we will put an inverse. Now then chain rule. Just apply chain rule and differentiate. Okay. minus 1. Consider this full, now dv by dx is nothing but minus 2 alpha x plus beta all raised to minus 2 into 2 alpha. Now everything is ready, just we need to substitute correctly, that's it, nothing else. Okay, so a is equal to dv by dx into dx by dt. Okay, so dx by dt is here, dx by dt is here, dv by, I will write this also, dv by dx is nothing but minus 1 by 2 alpha plus beta whole square. I put it in the denominator. So dv by dx is also ready. dv by dx is also ready now. Oh, now simple, we will substitute. Okay, so a is equal to, what is dv by dx? dv by dx is minus 2 alpha plus beta whole square into 2 alpha into dx by dt, it is here 1 by 2 alpha x plus beta. Bas. Now we have already written like what is velocity v. Already velocity v we found as 1 by 2 alpha plus beta. This is what is velocity. Now what we do, 1 by 2 alpha plus beta is velocity, means here a is equal to 1 by 2 alpha plus beta whole cube. This one and this together, this is going to be all cube into 2 alpha. So 1 by 2 alpha plus beta is velocity. So what we will do here, this is nothing but v cube into 2 alpha. Writing in the correct form, this is 2 alpha v cube. This is what is acceleration, 2 alpha v cube. Clear? So bit difficult question, I agree, but this is the maximum twist or difficulty they can ask in this category. This question mainly we can expect these kind of questions in JEE mains or JEE advanced also. For NEET they may not ask this much application oriented, but this question is bit difficult. But the same chain rule, it's the same, this formula like a is equal to dv by dx into dx by dt. This form can be tested in much easier method in NEET exams, but definitely if we study with the NEET standard we won't be able to crack it. We should study much above. So we will be trying to teach you with a good standard, little above NEET, okay, little above JEE mains also, almost JEE main level, and some advanced questions also we will discuss in between. So this question is nothing but, if they give the question as function of x, t is equal to, time is equal to function of x, then what we need to do is take this formula, a is equal to dv by dx, dx by dt. dt by dx can be done. After that put the reciprocal. This is nothing but velocity. This is what? This is actually velocity. So by differentiating that velocity with respect to x and substituting, we will be able to get the answer. Clear or what? This is a very good question. Note it down. Okay, so no need to get afraid by seeing these kind of questions. We must do very good standard questions so that we will be able to deal questions in the exams, okay, with much courage. Okay, this question they have asked in NCERT exam long years back. Okay, students, this is your next question. If displacement of a particle is directly proportional to square of time, then the particle is moving with, these are the options: uniform acceleration, variable acceleration, uniform velocity. Variable acceleration but uniform velocity. This fourth option makes any sense or what? Acceleration itself is variable, okay, but the particle is moving with the uniform velocity. Absolutely not possible when I think. Okay, So 3 options we need to check whether they are correct or not. So what we need to do, we will check velocity and acceleration. If velocity is a function of time, then definitely velocity will change as time changes. If acceleration is a function of time, then definitely we can think that the acceleration will change with respect to time, because see this. So we have displacement is proportional to square of time. So we can write like a constant into t square. Clear? Now what is velocity? Dx by dt, differentiation of this is going to be 2 kt. So when we put time t is equal to 1, 2, 3, likewise velocity will be changing. The value of velocity will change. Velocity varies. So definitely this is going to be not uniform velocity. This is also not possible. Whether it is uniform acceleration or variable acceleration, let's see. A is equal to dv by dt. Just where is velocity? Yeah, here. So differentiate this, we will be getting 2k. T is not there, so t is equal to 1, 2, 3. Even whatever we change time, this 2k will not change. So this is going to be uniform acceleration. Did you get these points, pa? If t is there in the equation, t is nothing but time. So when t changes, this equation will change. Not equation, the value will change. Correct or what? So using that, so this method, differentiation method, this mathematical tool is so powerful that we will be able to analyze all these kind of questions. So dear students, see, we have studied differentiation, mathematics by putting proper basics only, we have reached here. Okay, so practice differentiation formulas, then attend these questions. Take any book of your choice, do maximum questions as possible from this area. If you see integration, don't touch that, we haven't started. Okay, next session we will be coming with the mathematics for physics, and we will be learning integration and problems associated with that. So whatever maths is required for physics, everything we are addressing here. Okay, so you just follow the lessons and practice. Okay, the problems which we are discussing in the classrooms and the problems which you are getting for the exam, apart from that, after practicing and revising all the problems in your class, you must do some extra effort also. Maintain a book for that itself, book for you, like whatever extra good questions you are getting, you can note it down without wasting much time. Okay, don't waste much time on writing the books, but you should have notes for exclusively for your revision and all. Okay, at least if you get few questions, either you can take printout and keep it, file it, whatever way possible, save the time. At the same time, when you do revision, all these questions must be handy, available nearby. Okay, that time you should not miss, like I did a question during that day, but I do not know where is that question. Should not be like that. All the questions that are difficult, all the twisting questions, whatever you do for revision, you should have an access into that. Okay, so do keep practicing, keep studying, and update on day-to-day basis. Okay students, thank you, goodbye, good luck.